as you are looking at your page 51, you want to make sure that you've written both decimal and scientific, and you've ranked them from the smallest, looking at your smallest negative exponent with your power of 10, to the largest, to your largest power, and then also looking at, if it helps you to look at the decimal or the scientific notation. I know the ones on the bottom of the page are the ones that kind of give the most problems. You want to be thinking, pick something small. These have to be in the decimal notation. Here you're going to pick something large, and you're going to take it times 50,000 to get the other answer. So it's a lot like the page 50 that we did. As you look at page 52 and you're simplifying, what we were really looking for is, as you look at these, you're the teacher, you got to find the mistakes. So when you are looking at these two problems, the biggest thing is we're trying to find what was the mistake as you looked at this. There's 2 of these that were correct out of the 5, and 3 of them that were wrong. And one of the hints to me is, like, if I'm looking at number 2, this really means negative 5 over 1. Oh, so negative 5 times 8, yep, that gives me negative 40. I have the b to the negative 8 here, still b to the negative 8, so that makes sense. I had 12 to the 0, that's a 1. Okay, so this 1 makes sense. I have the c and d to the negative 4. So everything up to this point is correct. And now this is where the mistake happened. And so what you want to tell me is that they did this part wrong, because this was c, should have stayed on top. So there's one more that is wrong on that page. We're not going to look at this quiz right now in the video, but we will look at that quiz in class. And as you look at G10, the key thing with G10 is we are going to be doing add, subtract, multiply, and divide. So we have all these operations that we are going to be doing today. We're going to start with the addition. When you do addition and subtraction with scientific notation, key phrase that I want you to remember is LARS. Operations use the LARS. Left, that stands for left, add, right, subtract. Left, add, right, subtract. And the thing I always want you to think of is that you want to go big. So whenever you are looking at adding 2 things, we can't add them when these are both 10 to the 5th and 10 to the 3rd. So instead, what we are going to take a look at doing is adding them and getting the same power. So both numbers must have to have the same power of 10. Notice they went down here to 10 to 10 to the 3rd power. You could have also had this as 2.8 times 10 to the 5th. And if we're going to go 10 to the 5th here, that means I need to go, if I need to move it 3 places, in this direction to the right, this would be 4, 5. This is going to be plus 0.0, and I'm moving it 2 places, 1, 5 times 10 to the 5th. So that when we add those, we get 2.815 10 to the 5th. This is our answer in scientific. So when we look, we want to make sure our powers are the same before we add. So as we look at this first one, we're going to they have the same power. We love this problem. We're going to just line it up, 4.7 times 10 to the 5th as we are looking at that. As you add those 2 together, we are going to get, as we look at our answer, 8.3 times 10 to the 5th. Oh, this one not as nice. We have a 10 to the 4th and 10 to the 3rd. So we are going to write this first one. We want them both to be 10 to the 4th. So if I'm looking at this first one, I'm going to rewrite it. And if I want 10 to the 4th, when I'm doing this in my workbook, this was telling me to move it over 3 places. If I move my decimal back to be 0.345, lining up your decimal points, we can now add this. If I add these together, I'm going to get 4.995 times 10 to the 4th. It is in scientific notation because the first number is between 1 and 10 times 10 to a power. Again, if you need to pause the video, do so. This next one, we have 15th power and 14th power. We're going to keep the 15th power, so we're going to rewrite it as 3.57 times 10 to the 15. Notice I left some space here. I'm going to go with another times 10 to the 15 because I know as I add those, I need to have it in that form. We are subtracting this time, and since I had 14 places, now I need to make it 15. This becomes 0.465. This was moving at 14. I want to change it to a 15 power. When we do this subtraction, it helps to put it in your calculator, 3.57 minus 0.465. We are ending up with 3.105, and it is times 10 to the 15. This last one that you're going to look at, we have our largest power is -1. So here, this one gets a little tricky. We want to put this one first. It is going to be a negative 2.1 times 10 to the -1. Larger power, 10 to the -1. This first one was moving it 2 places this way. Well, if we only have to move it 1, this is now going to be 0.945. And I know for some of you, this is the hardest part that you're like, I don't get this. Again, put this in your calculator. -2.1, and I know it originally was a subtraction, but this is positive, plus 0.945. When you do that, you're going to get a -1.155 times 10 to the -1. What does this look like in standard form? So this is my scientific. In standard form, it says to move it -1. It's going to be a small number. Move it 1 place to the left. So my answer would be -0.1155 as I am looking at that. So as you look on page 30 in your notes, on page 30, you are going to see this multiplication. When we do multiplication, it says that we are going to be multiplying the numbers in scientific notation. First, you multiply the coefficients. That means the 5.6 times 7.102. When you multiply those two numbers, you end up with 39.77112. We are going to say that that is approximately 39.8. We don't need to have all these numbers behind our decimal when we're doing scientific because it's a large or small number. Next, we're going to add the exponents. So if you would please write in here, same rules as before. When we added our exponents, we have the same base. We're adding 12 plus 4, which gives us 10 if we are looking at that, 10 to the 16th power. Now, when we look at that answer of 10 to the 16th, the most common thing to do is people go, oh, I'm going to put the 39.77, which we just said we are going to round that to 39.8 times 10 to the 16th. And now we've got to keep it in scientific notation. Well, this number is not a number between 1 and 10. It is telling us to move the decimal over 16 places, right? So if I was going to move it 16 places, if I now place the decimal between the 3 and the 9, I would now have to move it instead of 16, 17 places. So if I'm looking at this answer, we're going to put it as 33.98 times 10, and instead of 16, it's going to be to the 17th power. Make sure if you need to pause this to write it down that you do so. We're now going to look at division, but keep in mind, when you multiply x to the n times x to the n, same base here, you are adding those exponents, n plus n. So now when we look at division, again, I might write down my exponent rule that when I divide, I'm going to subtract. Now, a lot of times it's very similar to what we're going to do. We're going to divide the coefficients. So we're going to put in our calculator, and sometimes you'll see it written this way, 3.04 divided by 9.89. These two things mean the same thing as we are dividing. When you do that division, we are taking a look at 0.307. Now, there's a lot more numbers behind that. Usually, we're going to round it to the 2 or 3 decimal places. If we look back at this original problem, in the numerator, we had 10 to the 5th, and in the denominator, we had 10 to the 2nd. What are we going to do with our exponents? Well, when we divide, we subtract, so I should see 5 minus 2, which leaves me with 10 to the 3rd. So I have this answer down here. I put it together. I put the division, 3.07 times 10 to the 3rd, but not in scientific notation. This was telling me to move my decimal 3 places. Now I don't have to move it as far. So I'm going to have 3.07 times 10, in this case, to the second. Now, in standard form, what would this number look like? So this is the scientific notation that we are looking at this whole answer. But if I asked you to put it in standard form is simply going to be, we are going to have moving our decimal over 2 more places, 307. And sometimes that answer makes more sense, especially as we look at our story problems. So, we are going to do some practice with your multiplication on the top and division. So the top 2 are multiplication. So again, the first thing that I want you to write down is we are going to show our work as 4.8 times 1.2. We're going to do that multiplication. Please put that in your calculator. Then we're going to put in the back times our 10 to the 6th times 10 to the 3rd. When I multiply these two together, I get 5.8. That's nice. It's already a number between 1 and 10. Times, again, when we multiply, we add our exponents, so 10 to the 9th. I am done with the problem. Multiplication and division are a little easier than our division or than our addition and subtraction when we take a look at those. So as we take a look at this next one, as we are looking at this, we are again going to show what we multiply, because this was multiplication in between. So we're going to put 8.18, put that in your calculator, times 1.15 in your calculator. When we multiply that, another nice number, 9.407. Then I'm going to put the times 10 to the negative 6 and times 10 to the negative 5. Now the biggest mistake that I'll sometimes have students do is they think they want to make these positive. Scientific notation can have negative exponents, and we're not going to do the reciprocal. So negative 6 in my calculator plus a negative 5 gives me 10 to the negative 11. This is a super small number if we are thinking about this. This has the placeholder 0 and then 10 zeros, 947. This is a large number. This is 5, 8 with 8 zeros behind it. Okay, so just kind of keeping that in mind. So division, again, on your calculator, can you put in 5.3 divided by 7.65? Yes, put that in your calculator where you're using our calculators. That is not going to be a number between 1 and 10. So we're going to put 0. When we get that answer, 6928. Again, we don't need more than 2 to 3 numbers behind. We are looking at 10 to the 3rd divided by 10 to the 5th. So what are we doing with our exponents? We are taking 3 minus 5. That's going to leave us with 10 to the negative 2. If it's 10 to the negative 2, that means to move my decimal point 2 places to write it in standard. If I now place the decimal between the 6 and the 9, and I write 6.928, I have to move it not 2 places, but 1 more, 10 to the negative 3 as you look. Next problem as I'm doing it, I'm just doing this here. 4.6, we are going to divide it by 5.01. So we're going to do the division. Again, on your calculator, 0.9182 as you are. So we've divided on our calculator because it was a division problem. I am now going to take times, and I'm going to take 10 to the 2nd divided by 10 to the negative 3. Again, when I do this division, I am taking 10 to the 2nd minus the negative 3, which actually gives me 10 to the 5th. So I have 10 to the 5th, 0.9182. That means to move it over 5 places. But when I look at my answer, I have to get a number between 1 and 10. So when I do that, I should be looking at 9.182. And I don't have to move it as far, so instead of 10 to the 5th, 10 to the 4th. Again, use your calculator or write out that subtraction when you're doing the problem. The last 2 problems is we are kind of just trying to take a look and do comparisons. So it says, which operation do I need to do to solve this? So we're mostly looking at the operation. If I look at the Pacific Ocean is 6 times 10 to the 7 square miles. The area of the Atlantic is 2.96 times 10 to the 7 square miles. So they're very comparable, but Atlantic is smaller. how many times greater? Times greater, if we are looking at that, is trying to tell us to take times greater is the Pacific than the Atlantic. That really means that we want to take our Pacific Ocean as we are looking at that, and we are going to take, and we should be doing division. Which one do we want to divide? So when you look at this, how many times greater is the Pacific? So the Pacific was the 2.96, if we are looking at that. Almost 3, so it's like we're taking the Atlantic Ocean and dividing it by the Pacific Ocean. So how much greater is the Pacific than the Atlantic? 6, if we are looking at that, times 10 to the 7 divided by almost 3 times 10 to the 7th, and we would say it's about 2 times greater. In this next one, this one's a little trickier when people look at it. So the sun burns 4.4 times 10 to the 6th tons of hydrogen per second. So if you're thinking of writing that one, this is how it would look. 4.4 times 10 to the 6th, and this is tons of hydrogen, okay, per 1 second. That's what that means. Then it says, how much hydrogen does the sun burn in a year? So when we look at this, 1 year is equal to this many seconds. In order for my units to cancel, we are going to multiply, because I need the word seconds back here to unit multiplication. 3.16 times 10 to the 7th, the word seconds would cancel. And as I look at this problem, I am going to multiply. And when I multiply, if I was looking at this, I actually would multiply these two together. It's a pretty big number, and my answer would be in tons of hydrogen. So your homework tonight, as you are taking a look, is G10. First thing you're going to do is rank them from smallest to largest. Question number 2 is a difference, so you're going to subtract. Number 3, if you are looking at number 3, so you have subtraction. Total mass. So when you look at the total mass ones, again here a difference, subtract. And then the next page, so you're going to write out the problems, make sure you have the same power. As you look at the next page, again, 7 through 10 are your multiplication and division, be careful. And as I look at this first one, number 6, it's an addition problem. Again, here it says determine the operation. You don't have to solve. So you can simply tell me the operation that you are planning to do. Hope the homework goes well, and we will take a look at this tomorrow in class.